Hi guys, good morning. Hey, I just wanted to let you guys know that I'm thinking about you. I know it's tough to not be able to go back for your senior year, so hang in there, guys. I'm just going to go over the review. I probably won't do every question. I'll just do a few from each section. So state the total number of complex zeros and then state any missing zeros. So remember, if we're given zeros that have i's in them, complex zeros are called, then remember that the complex conjugate is also a zero. So here, if I'm looking at this, the total number of complex zeros would be 3 because that's the highest exponent. It's giving me 2 of them, but because I square roots of 3 is one of them, then I know negative I square root of 3 would be another one. So negative I square root of 3 and then the 2 that are given to me are all 3 of them. So I don't really need to do any math here. I just need to find those complex conjugates. So for example, on number 2, again, there are 3 total. It's giving me 2 of them. It's giving me 1 plus 3i and negative 2i. Because 1 plus 3i is a 0, I know the other one has to be 1 minus 3i. So those are the 3. Okay. On number 3 and 4, no, just 3, there's a multiplicity here. So it's just telling me that I square root of 3 is happening 2 times. So there's 1 I square root of 3, 2 I square root of 3. And because I square root of 3 is a 0 twice, negative I square root of 3 has to be the 0 twice. So there's 4 altogether. There's 1, 2, 3, and 4. All right, let's skip down here. State the number of complex zeros and the possible number of real and imaginary zeros for each function. So we know that the number of complex zeros is 3, so that would be the total again. There are 3 altogether. So how many could be real and how many could be imaginary? So remember, imaginary have to come in pairs. So there can be none. We could have 0 imaginary. 1, 2, or 3. Let's see which ones of these actually work. We can't have 1 or 3 because if we have 1 or 3, we would be left with an odd number of imaginary, or we would have that would be an odd number of imaginary. So real, I can't have 0 because if I had 0 real, that would leave 3 of them to be imaginary, and I can't have an odd number of imaginary. I could have 1 real because that would leave me with 2 imaginary. I cannot have 2 real because if 2 were real, that would mean only 1 was imaginary. I can't have an odd number of imaginary. Or all 3 of them could be real. So if for imaginary, I could have 0 or 2. For real, I could have 1 or 3. So exactly the same thing here because it's also third degree. So I could have 0 or 2 imaginary and 1 and 3 real. 1 or 3 real. So that's all based off keeping those imaginary ones even and that the real and the imaginary add to the total. All right, factor each polynomial as a product of linear factors. So remember, linear factors means all of my x's will be to the first degree. And I'll just have them lined up with the parentheses. Okay, so this one will have, since it's x to the third power, will have 3 sets of parentheses. So I'm going to start by grouping the first 2. Remember, if there's a minus between, we got to pull that minus in and change that to a plus so that we don't change the sign of 10 accidentally. So x to the third and negative 5x squared have a common factor of x squared. So I'll pull that out and I'll be left with x minus 5. Negative 2x and 10 have a common factor of negative 2. So I'll pull that negative 2 out and I'll be left with x minus 5. Remember, you can always double check, make sure if you were to multiply that back in, you get the same thing we got here. These both have x minus 5 in them. So I'll pull that x minus 5 out front because that's now the common factor. And that leaves me with x squared minus 2. Now x squared minus 2, that's not linear yet. It's still squared. So in order to get that in as a linear factor, I'm actually going to set it equal to 0. And I'm going to solve for x by adding 2 to both sides. So x squared equals 2. And then I'm going to take the square root of both sides. Remember, if you're taking the square root of a variable, you could have the positive or the negative of that solution. So I could actually write this as x minus 5, and then I have a 0 of positive square root of 2, which would make a factor of x minus square root of 2. And then I have a 0 of negative square root of 2, which would make a factor of x plus square root of 2. So now that all three of my x's are just x's to the first degree, now it's a product of linear factors. Now if it asked me to actually find the zeros, I would want to set these all equal to 0 and solve. I actually already found 2 of the zeros. That's not what it's asking me to do here. It's asking me to write it as a product of linear factors. Okay, on number 8, since the first term is 4th degree and the middle term is 2nd degree, I can factor this using x factoring. The only difference being when I put my x's in here, they're going to have to be to the 2nd degree. So I'm looking for two numbers that multiply to a times c, which would be 48, and add to negative 14. So let's see, we could do 6 and 8. And if they're both negative, they will multiply to a positive 48 and add to a negative 14. So x squared minus 6 times x squared minus 8. Again, we wanted these to be linear, so we have to go one step further so that each of our x's is only to the first degree. So in order to find my factors here, since there are no two numbers that multiply to 6 and add to 0, I'm going to have to solve this. Set it equal to 0 and solve to find my zeros. So take the square root, and x is going to be plus or minus the square root of 6. So this would be x minus the square root of 6, x plus the square root of 6. I would do the same thing to x squared minus 8 to get plus square root of 8 and minus square root of 8. So that would be the product of linear factors. Okay. Technically, square root of 8 reduces to 2 square roots of 2, or simplifies to that. So you could put x plus 2 square roots of 2, x minus 2 square roots of 2. I'm not as worried about that as just making sure you know how to put it in as a product of linear factors. Okay, in the next section, we have a 0 given, and we need to find the others. So to find the others, since this is not a factorable polynomial, we're going to use synthetic division to divide using that 0 that is given to us. So that'd be 5, negative 19, 22, and negative 8. This is going to be our remainder. Remember, since this is a given 0, my remainder should be 0. If I don't get a remainder of 0, it means I made a mistake somewhere. So pull down that 5. 2 and 5 is 10. Negative 19 and 10 is negative 9. 2 and negative 9 is negative 18. And 22 minus 18 is 4. And 2 times 4 is 8. So we do get our 0 here. So that means, remember, always go down 1 degree from that one. This will be 5x squared minus x plus 4. So now this one we can x factor to find those other two zeros. Remember, it should have 3 total. It's giving us 1. We need to find the other 2 by factoring this. So a is 5, c is 4, 5 times 4 is 20. I'm looking for two numbers that multiply to 20 and add to negative 9. So that would be negative 5 and negative 4. They multiply to positive 20. They add to negative 9. So x minus 5 times x minus 4. Remember, we always need to divide by a when it's not 1. And this would give me x minus 1 times 5x minus 4. But again, we were trying to find the 0, so we've got to take each of these, set them equal to 0, and solve. So for x minus 1, we would have a positive 1. And then, well, I can't circle that for some reason. For 5x plus 4, I'm sorry, 5x minus 4, we would add 4 to both sides. So 5x equals 4, and then divide by 5. So x equals 4/5 and 1. Okay, so those are the other two. So I have a 0, 2, 1, and 4/5. All right, so I'm going to actually skip down now. We have identify the wholes, vertical asymptotes, and domain. So remember, the first thing you want to do when you're looking for these things is factor the numerator and the denominator. So on the top, I'm going to pull out the common factor of x, which will be x minus 3. On the bottom, same thing, x, which leaves x plus 2. The domain is going to be any value that makes the denominator equal 0. So in this case, we have to exclude those values because we don't want it to equal 0. So for x, it would be x cannot be 0. For x plus 2, it would be x cannot equal negative 2. Now, 0 and negative 2 are either going to be wholes or they're going to be vertical asymptotes. So check for holes first. Holes happen when something cancels out. So since this x over x would cancel out, and that happens at the 0, there is a hole at x equals 0. The vertical asymptote is going to be whatever is left over after the holes are canceled out. So there would be a vertical asymptote at -2. Okay, let's do one more. Let's do let's do 12. So on the top here, I can pull out an x, which would leave x squared plus 4x plus 3. On the bottom, I can pull out, let's do a -3x, which would leave x plus 2. And then I need to factor x factor, not up there apparently, this part in here. So what multiplies to 3 and adds to 4 would just be 3 and 1. So we got x plus 3, x plus 1, -3x, and x plus 2. So the domain, because I'm looking at the denominator only, the x here, -3x, if I set that equal to 0 and solve for x, I'm going to get that x cannot be 0. For x plus 2, it can't be -2. Now remember, each of these is either a hole or a vertical asymptote. In this case, there is a hole because x cancels with x. That happens at the 0, so there's a hole at x equals 0. And since 2 is left on the bottom, or x plus 2 is left on the bottom, didn't cancel out, that -2 is a vertical asymptote. Okay, so let's go ahead and skip down some more. The horizontal asymptote, remember we need to check the degree in the numerator and in the denominator. If it is big over small, then there is no horizontal asymptote. If it's small over big, there's a horizontal asymptote at y equals 0. And if it's the same over the same, then it's going to be at leading coefficient over leading coefficient. Excuse me. So number 15, the degree on the top is 0, the degree on the bottom is 1, so that would be smaller over bigger. So this one has a horizontal asymptote at y equals 0. On number 16, it's bigger over smaller because the degree on top is 2 and the one on the bottom is 1. So this one would have no horizontal asymptote or none. 17 is the same over the same. So the leading coefficient on the top is 1 and the leading coefficient on the bottom is -2. So there would be a horizontal asymptote at y equals -1/2. This one is also second degree over second degree, so y equals leading coefficient of -3 over 1, which is just equal to -3. Okay, and then lastly, we need to look at these sketching the graph ones. Let's look at number 20. So we're going to need to factor just like what we did before. So on the top, I'm going to pull out an x, which would leave x plus 3. On the bottom, I'm going to pull out a 4x, which would leave x minus 4. So the domain, remember just looking at the denominator, x cannot be 0 or 4. 0 from the 4x or 4 from the x minus 4. There is a hole at x equals 0 because that x cancels with that one. And then the vertical asymptote would be at the 4. So, oh, and the horizontal asymptote, go back to the beginning, second degree over second degree, so just 1 over 4. So I have that horizontal asymptote here at 1/4. I have a vertical asymptote at 4. Put those on first. My hole is at 0. So after x gets canceled out, this is just left as x plus 3 over 4 times x minus 4. So after that cancels out, if I want to find the y value of where that hole is, I'm going to plug in the 0. So that would be 0 plus 3 over 4 times 0 minus 4, which is 3 over 4 times -4, or 3 over -16. So -3/16, which is just fairly down from 0. So when, let's see, when x is 0, y is -3/16. So up here at 0, it's going to be right below here. So my hole is going to be in here somewhere. which means my curve is going to be in this quadrant and this one. Remember, they're always kitty corner from one another. So let's actually do number 19 as well. So on the top, I'm going to pull out a 3, which leaves x plus 3. On the bottom, it's just x plus 1. So the domain here would be we need to exclude negative 1. X cannot be negative 1. There are no holes. The vertical asymptote is at negative 1, and then the horizontal asymptote, if I look at the degree of the top and the bottom, they're the same, so it would be at 3 over 1. So there's a horizontal asymptote at 3, and a vertical asymptote at negative 1. This one has no holes, so I don't need to worry about where the hole is, but I just need to figure out which two quadrants my curve is in, so I can choose any x value except for the vertical asymptote, so let's just do 0. If I plug 0 into the function, and again, I can plug it into either the one that's factored or the one that's not, they're both the same. When you have a hole, you have to do it after it's been canceled, but when it's not a hole, you can just use either version. So this would be 3 times 0 is 0, so this would just be 9 over 1. So when x is 0, y is 9. So it's going to be up here somewhere, which means this quadrant and this one would be where my graph was. All right, guys, test coming up tomorrow. So just review this and have a great day.